What I want to show you in this video is what could be described as, I guess, a trick for finding binomial expansions, especially binomial expansions where the exponent is fairly large. But what I want you to do after this video is think about how this connects to the binomial theorem and how it connects to Pascal's triangle. So now let me show you the trick. So I'm going to take x plus y to the 7th power. That's going to have 8 terms. How do I know that? Well, x plus y to the first power has 2 terms. It's a binomial. X plus y squared has 3 terms. X plus y to the 3rd power has 4 terms. So this is going to have 8 terms. So let me just create little buckets for each of the terms. So this is the bucket. These aren't the coefficients. These are just the buckets. First term, second term, third term, fourth term, fifth term, sixth term, seventh term, and 8th term. Now let's write out the actual x's and y's. So the first term we're going to start with x to the 7th power. Then each term after that, our degree or our power on the x goes down by 1. So you go x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, we could just write that as x, and this is going to be x to the 0, which is just going to be 1. And now let's think about y. This is going to start at y to the 0, which is just 1, so I'm not going to write it. Then it's going to be y to the 1st power, y squared, y to the 3rd power, y to the 4th power, y to the 5th power, y to the 6th power, and then y to the 7th power. And you can verify you got it right because for each term, the exponents should add up to 7. You see that even here. This is x to the 1st times y to the 6th. Those add up to be 7. Now let's get to the interesting part, which is actually calculating the coefficient. And the algorithm is for each term right over here. So let's just start. We know the coefficient right over here is going to be 1. Actually, let me write that down. The coefficient over here is going to be 1. So for each term, the coefficient right over here, the coefficient, I'm going to try to color code it so we can see it. The coefficient is going to be the exponent of the previous term. So the exponent of the previous term in this case is the 7. The exponent of the previous term times the coefficient of the previous term times the coefficient of the previous term divided by which term that actually was. So divided by the term. So that was the first term. So now the coefficient on the second term is 7 times 1 divided by 7, which is going to be equal to 7. Which is going to be equal to 7. Now what about this one? Well, we use the exact same process. The exact same process. It is going to be the exponent on the x term. I guess you could say the exponent on x, I guess we could go with. The exponent on the x, which is 6, times the coefficient of the previous term, so times 7. So we're taking the x power times the coefficient of the previous term, so times 7. So the x power of the previous term times the coefficient of the previous term divided by the actual, I guess you could say, index of the previous term. So divided by 2. So what is that going to be? So this is equivalent to 3 times 7. So this is going to be equal to 21. And now let's go to this term. Exact same idea. Go to the previous term. What's our exponent on x? It is 5. Let's multiply it times the coefficient. So let's multiply it times 21. And then let's divide it by which term that is. So that was the 3rd term. The 3rd term. And so this is going to be, let's see, 5 times 21 over 3 is 7. So this is going to be 35. 5 times 7. And we can keep going, or we can recognize that there's a symmetry here. If this is 1, then the last term is also going to be 1. If this is 7, then if the second term is 7, then the second to last term is 7. If this term is 20, if the third term is 21, then the third term to the last is 21. And then if the fourth term is 35, then the fourth from the last is 35. And just like that, we have figured out the expansion of x plus y to the 7th power. Pretty neat in my mind.